Okay. Good. Good afternoon. Come on, a bit better than that, guys. Hey, there we go. All right, apparently I have shirts to give away for some contest you guys are doing. You have to decode this, is that the deal? So I've got 3 of those, so if you ask questions, I'll chuck one out to you guys somewhere. So welcome to server 317. I had to stay near the camera for a few seconds, but I do like to walk around a bit. So my name's Jeff Alexander. I'm an IT Pro evangelist based out of Microsoft in Sydney. I just had my anniversary at Microsoft last week. Anybody want to gander how long I've been at the company?
6 months.
6 months. Wrong. Way off. 23 years last week. So I've spent 6 years in Microsoft's internal IT department. And when I did that, we were Windows Server 2003 was the operating system that we had out at that particular time. And there was this marketing campaign going on in Australia called Do More with Less. And I did a server consolidation project, and I ended up being the less part. So I had to go and find a job somewhere else. So I ended up doing this. That's my blog, blogs.technic.com/Jeffer36. So this session's all about a new feature in Windows Server 2008 R2 and Windows 7. How many of you got R2 servers in your environments yet? Okay. How many of you got Windows 7 in your environments? You usually feel your hands go up at that point in time. So how many of you have branches in your environment? Okay. How many of you are a branch? Okay, a few of you guys. Okay. So I'm going to talk about how we accelerate the experience for your users in your branch offices. Do your users complain much? That's always a question I get. I ask that because I know I'm going to get a yes on that. And where do they normally complain? In the branch offices. Because when I used to manage our IT department, that was where we get a lot of the complaints, is in the branch office. So today I'm going to kind of talk about what the problem we're trying to solve here today with BranchCache. Talk a little bit about, show you how it works. I've got some demos back in Sydney on my servers. If you read my blog, I did a post on the servers that I'm actually using for this particular demos. And I'll also explain how you can go about and deploy it and dive down into some of the nitty-gritty parts of how we're actually dealing with the data that's going around, so you can see what that actually looks like. So this is kind of the agenda of what we're going to do. The deep dives are towards the end. I did this session in TechEd Australia last week. Got to the deep dives and I only had about 10 minutes left. So I'm going to try to get through the rest of it. I've cut stuff that I had in the one in Australia because we only have 60 minutes here as opposed to 75 minutes in Australia. So that's kind of where we're going to go to, but I really want to talk about what problem that we're actually trying to solve. Now, if you look at where we started BranchCache, for those of you that have been running server in your environments, when did we start doing some BranchCache stuff in our products? Anybody got an idea, sort of? It was Server 2003 R2 was when we started the journey about making the branch a better experience for our users. We started implementing some stuff around DFS and DFSR and that kind of stuff to make the branch experience a bit better. So the problem space that we're trying to identify is that you guys all mentioned that you had branches, right? What's typical of branch offices? Hey? Slow networks. What's a typical link here in New Zealand? I'm not going to try to do a New Zealand accent. I'm just not going to go there. Hey?
Telephone, one office.
One office. What's the speed like?
Well, it can be 512K, 1 megabyte.
512 to 1 megabyte? Okay, good. Now, what invariably means is that we're trying to pump an application down to a user in a branch office that was never designed to run in a branch office. Because oftentimes the application was developed to run over very good links. Okay? That costs you a lot of dollars, doesn't it, to manage these WAN links. And then you multiply that out into a whole bunch of different servers, you get more money. And this is typically what happens is you've got these amount of branch offices with moving parts in those branch offices. Thin WAN links cause a bad experience for the user. And they tend to complain more, but they're trying to do the same job as somebody that might be in a head office. So it causes a bit of a problem there. So that's kind of the space that we've got there. What we've introduced with BranchCache is 2 different types of modes. Any of you been playing around with BranchCache yet? Okay, so nobody has. That's good. So hopefully you'll learn about what we've got. The first one is distributed mode. So here we've got a scenario of two users that are in a branch office. The user on the bottom part of the screen is a very keen user, gets in about 8 o'clock in the morning. Okay, and they want to go up to the server and they want to get a file. And what they tend to do is they might go over a link, because users don't know the difference between a server that sits locally to them or a server that's over a WAN link. Okay, so they'll do a get, and they'll go and try to get that file. Okay, so they'll go to the head office server. Now, these machines in this branch office are running Windows 7 Enterprise, and we have R2 on the server that they're going to, assuming that a BranchCache is enabled. So they'll do a get, and instead of downloading the data to the user's machine, we'll download a tiny piece of metadata. Okay, so the piece of metadata, and I'll talk about what that piece of metadata is broken up to. It's around about 64K in size that we download that really gives us an identifier or a segment ID for that data to tell us what that data is. Okay, and then what they'll do is they'll do what we call a shout out, or a multicache shout out to the branch, because they're running in peer distribution mode, which in peer disk is a new part of the protocol that we've added to TCP to allow us to do that peer discovery. Okay, so they'll go and do a shout out to say, hey, does anybody else in this branch office have this matching hash ID? And I'll talk about the security part of that a little bit later on. So they look for that matching file, and they see, okay, well, we don't have this in the branch office, so I'm going to have to traverse back over the WAN to get the entire file. Okay, so they have to pull that file down. So the first experience is going to be like what you would have normally. Okay. Now, 8:30 in the morning, next user comes in, so they go and do a get as well. So they're going to go and get the same file that the other person got. They go and grab that file. They do the same thing. They're going to download some metadata about that file. Now, that metadata has already been taken care of by BranchCache and broken down into a hash ID, which I'll talk about a little bit later on. That then they'll go and do a shout out amongst the branch, and they'll say, okay, has anybody got this matching 256K SHA? Because that's how we actually break it down. And do they have the same hash ID? They'll match it up, and instead of grabbing it from the server, they pull the file from that first user. Okay, and it dramatically improves the experience that the second user is going to have, and subsequent users after that. Okay, so that's where we're actually pulling the data down. Makes the experience a lot faster for them, and I'll talk about the protocols that we use for that. Same thing in hosted cache. Now, of course, in a distributed cache type environment, a user might leave with their laptop, okay, and they might, shut it down for whatever reason. What that means is then all of a sudden the second user has to go over the WAN. Okay, so with a hosted cache mode, it works a little bit differently, and we have a little bit more security that's involved between the client that's sitting in the branch and the hosted cache server itself. Okay, so we have a little bit more security there. Same scenario where they do a get and they do a shout out. We search to see if there's because now we're running in hosted cache mode, because when you do a netsh BranchCache show all, you can determine what mode you're actually running in. Now, this particular scenario, the user is running in hosted cache mode, and they've been assigned a hosted cache server. They look on that server to see if the content is local. Then what they'll do is they'll do a get. They notice that the content is not there locally here. Now, what we're doing between the server here is we're going to do an offer of that data to the hosted cache. Now, we have to preserve all the authentication mechanisms that we do. So there's a certificate that has to be communicated between the server and the client to verify that this user is who they say they are. Okay, so there's some additional security that's on the BranchCache hosted server. The offer is sent, then the request is satisfied from the cache, and then we'll do a put back to that particular server. Now, the second user does the same thing, and I'll just build this out. They'll go and do a search. They'll see that there's a matching hash ID. They'll go and do a get, and they'll get the data from the hosted cache instead of going over the WAN, because the first client already offered that data to the first user. Okay, so this is kind of when you look at hosted cache mode versus distributed cache mode and why you would actually run it. So if you're looking at an office, a distributed cache mode, you might have an office. I think you said an office is with no users or something like that. So does anybody have offices where you have no IT staff there? You just have users. Okay, that would be a good place for you to use distributed cache mode, because then each user becomes a peer of each other. So it's easy to deploy. It's very simple to deploy it over group policy. The experience when laptops go offline is a lot more seamless. But when they go offline, they're going to go into offline mode. Hosted cache is recommended for typically offices that have more than 100 users. and where you've got a server that sits in that particular office. Okay, cache availability is high. The other thing I want to point out here is that when you're in distributed cache mode, you have to be on the same subnet. Okay, when hosted cache mode, we can do the entire branch and go across subnets. Okay, it's just one thing to point out when we're deploying each one.
Can you use mixed mode?
Pardon me?
Can you use a mixed mode?
Can we use a mixed mode?
Distributed and-
Pardon me?
Can you use distributed and hosted?
So the question is, can you use distributed and hosted? No, it's one or the other in that particular scenario. So I'll talk about protocols and workloads and really point out that BranchCache itself is a platform. It's an API that we've built into Server 2008 R2 and Windows 7, and hence that's why you need those platforms to support BranchCache. So there's a peer distribution APIs that get the identifiers of the data itself that are on the server. Okay? And then we store those IDs, they're packed into the information structure store, into the content store. And then on the, when we look at, in order for us to accelerate that data, it contains everything that the client needs. So the protocols talk to each other to be able to accelerate that data. And then we have some peer dist APIs to find content. So where we can do the shout out and multicast and all that kind of information. And this is kind of how it looks like, and looking at the protocols that we actually support. So right now, if you look at, for this, BranchCache across the bottom is the platform that's built into R2 and Windows 7. And then we support SMB 2.1, which is supporting applications that take advantage of the SMB protocol. Things like copy file, things like Explorer, Office. We support HTTP 1.1 and HTTPS, and we also support bits for applications like WSUS and System Center Configuration Manager. Okay, so those are the protocols that we currently support. Over on SharePoint, Office, IE, all those things support HTTP. So can you imagine if a user goes up to an internal line of business web application? We can accelerate the experience for every user after the first one with web pages so that that page loads a lot quicker for them. Okay? So, Configuration Manager, before I get to a demo, I'll talk about some of the things that you can do with Config Manager and WSUS. Essentially what it does is it allows us to reduce the WAN utilization in the remote office, reduce the number of actively managed distribution points, because when you're deploying SCCM, you have these distribution points around. So we can accelerate the content. So distribution points need to run Windows Server 2008 R2, and we can help accelerate this traffic, meaning that the packages that we're going to send to the users, so when we're going to deploy updates to those users, those particular packages can downloaded once, and then the clients can get them from other clients in the branch. So any updates that they're getting from WSUS or from SCCM can be pumped from the clients. Okay, so they can share that across. Same thing with AppV. How many of you are looking at AppV at all for your deployments? Okay, a few people. Right, AppV is great technology in allowing you to decouple the application layer in your standard operating environment. So when you look at that, this is going to help you to save IT infrastructure, because the way we stream AppV applications, we can optimize that via BranchCache, because we can take advantage of the acceleration that we've got in BranchCache to do that. And it eliminates us not having to have IIS servers so AppV staging servers in the branch office. So that allows us to do that as well. So the other two common ones obviously is that SharePoint and IIS. Using the WinINet protocol, we can accelerate this protocol. Your SharePoint servers need to run R2. So if you want to install this, you've got to have R2 on those servers at that endpoint. The other thing got to be a thing about is that if the content actually changes, this is the thing I get a lot of questions about. So what if the content changes? Okay, so if the content does change on the website, users will go and grab another identifier. Okay, so when they do their shout out to get that data, they're going to look to see if the identifier has actually changed. And I'll talk about how we break the content up into chunks and how we break it up into segments and blocks and all that kind of stuff. I'll talk about that a little bit later. Kind of ease you into this before we get down to really technical stuff later on. So, file servers, obviously, these are one of the ones we support. Now, if you look at, how many of you went to Vista? That's always it's like a lake that's really quiet when you ask if anybody went to Vista. Nobody went to that. Okay, what was one of the biggest changes we made in Windows Vista? TCP/IP stack was changed. SMB protocol was also changed as well. So in version 1 of the SMB protocol, it was a very chatty protocol, okay, in the way that it actually delivered data over the network. Back in the 90s when SMB was originally introduced in Windows, we were moving a lot less big files. We were moving smaller files at that point in time. Now with SMB 2.1, this helps us to improve WAN utilization and the way that the files get moved around. So SMB 2.1 introduces leasing and opportunity locks, which allows us to be more robust with the data and how we're moving it around. So BranchCache integration assures that that data only moves once over the WAN and then gets cached in the local branch office or on the hosted cache server. So in SMB transparent caching allows us to, if you've got laptops in your organization, it allows your road warriors to work a little bit better in that scenario as well. So all applications, offline files are much better. If you haven't gone if you remember offline files in Windows XP, it's not as good as what we're seeing today in Windows 7. It's a lot more transparent to the user going forward. Both of these require Windows 7 and Windows Server. So to look at the end-to-end scenarios and kind of talk about this in a little bit more detail about what we're talking about. Any of you looking at things like direct access or IPsec? Nobody at this point? Okay. So essentially what these scenarios, when we talk about end-to-end, so if you've got users that are on direct access, which I'm on that now, I'm going to connect to my servers back in Sydney that way, the encrypted transports work correctly, okay, in the way that we communicate. A lot of people ask about where does BranchCache actually hit the data though? Okay, so when you look at this, essentially we have a communication of data between an IIS server and a user grabbing data from a Windows 7 client. Okay, so essentially what happens here, and this is talking about where data is in the clear and where data is actually encrypted. Okay, so when we look at the server, comes down from the IIS server, and at that point in time, the data is actually in the clear. Keep in mind, see where the BranchCache protocol is actually sitting at this point in time. Okay, so we move down through the http.sys file, then we go down into SSL. At that point, this is where we do the encryption. Okay, so data is encrypted down through SSL, down through the sockets layer, down through IPsec, and across the channel, over to a user that's running IPsec on their client. Okay, at this point, the data is still encrypted. The user has grabbed that data encrypted. We then have to go in with SSL, as we go up through sockets and go through SSL, the data has to be in the clear. At this point, this is where BranchCache is there. Okay, now a lot of people get concerned that the data in BranchCache is actually sitting in clear text, which it is. Okay, so what that means, though, is that you can use EFS or BitLocker if you're worried about the data on the user's machine. And I'll talk about where that's actually stored. Okay, so that's kind of where BranchCache actually sits. We're in the clear at that point in time. So we're sitting in clear text at that point. Okay, so deployment and management, and talking about how you would actually enable it for these different scenarios for BranchCache itself. So essentially, what you need to do is it's actually quite straightforward how you go about doing this. Essentially, what you do is you use group policy to enable BranchCache on your Windows clients, or you can use NetSH or the net shell to do that. So you install the optional Windows BranchCache component on an R2 web or file server. So when you install a web server, there's a tick box for installing BranchCache. And then for the file servers, there's a tick box to install BranchCache for network files. Okay, so that's the two options, and I'll show you what that looks like. Then what you do is the other option you have is you have to install a hosted cache in your branch, and you have to configure your clients through group policy to actually use that hosted cache server. And then we have to have a certificate so that there's authentication of communication between the clients and the hosted cache server. So that hosted cache server has to have a cert on it. So it's best to have a PKI stood up in your environment. So let's look at the content server itself. There's only these two steps. It's pretty straightforward. It's pretty easy to go and configure. Okay, HTTP service, you install that from Server Manager, install the BranchCache role service, and that's it. Does that sound too easy? I could get some nodding heads. Yes, it sounds a bit too easy after lunch. So here's what it looks like in a bit more detail. So distributed cache, hosted headquarters content server, server 2008, branch Windows 7. A hosted cache, the only other piece is the hosted cache runs that Windows Server 2008 R2. Yes, sir?
Windows 7, can that just be your standard version?
No.
Is it the enterprise?
Has to be Enterprise or Ultimate. So the question's around what version of Windows is that going to be. It's not in the Professional Edition if that's what you're... It's in Enterprise or Ultimate. Okay? So those are the components that get in for the branch cache deployment. On a distributed mode, how do you go and actually do this? How do you identify what a branch is? Okay, so at this point in time, what you want to do is you want to basically look at the best way to identify the branch is an Active Directory site. You can also do it by IP address range. You can also do it by a collection of specific client computers, so they don't need to be domain joined at that point in time. Ways to deploy is through group policy. We've added the branch cache interface to NetSH, so you can go do NetSH branch cache help, and you can find out all the commands you can do with that. You can turn on distributed mode, turn on hosted mode through NetSH. And then we have a group policy. We have a built-in ADMX file for managing branch cache through computer management there. So this one here will say run NetSH branch cache to set your service to distributed. Pretty straightforward to do that. On a hosted cache, so you have to install a branch cache feature on an R2 server. Then you have to install a self-auth certificate for use with SSL. And then set your hosted cache server. So set that server to be run at NetSH branch cache to set that server to the hosted cache server. So that's the hosted one. Identify the branch, same way we did before. And then choose how you're going to deploy via group policy, or you're going to do it through NetSH that way. Most people would do it through group policy. Now, a lot of people ask about, how can we monitor this? We have a bunch of ways to monitor this, and I'm going to show you in a demo a little bit how we can actually monitor where the data is coming from. So event logs, of course, we've got operational logs, audit logs, all that kind of, the same logs are actually there. And then if you go into the perfmon counters, we can see where the data is coming from, whether it's coming out of the cache, whether it's coming out from the server as well, so you can see where the data is coming in your environment itself. You can also use NetSH for looking at your cache, whether your cache size is too small, whether you have firewall problems. When you actually go through and actually enable branch cache, it'll open up the ports in the firewall for branch cache. And we already have some rules pre-done for that on Windows 7 and R2. The other thing you can do is you can go and change the size of your cache as well. By default, we reserve 5% of the user's disk space to cache content. And we periodically flush that data out that's stale. Okay? If you're worried about some data that's sitting there, you can go and do a NetSH branch cache and flush to flush that data out of the cache itself. Okay? So we also, for SCOM 2007 R2, there was a MOM pack to get an all-up view of where the data is, how much data you actually are using. Now, our MSIT guys, I'm going to show you a slide later on, are using MOM to see how much they're actually saving, how much data is going over cache, and how much is going over the server. And you'll see they're getting a lot of it being used by cache, so that saves them a lot of time. So, what's the average attention span for the average adult? Especially after lunch. It's about 20 minutes. And what happens? You get stagnant hypoxia, which means your blood gets cut off to your neck and you go to sleep. So that's why I'm going to switch and show you a demo. So a couple of things I want to show you is I want to show you how you go and set up a file server. Then I'm going to show you where the settings are for group policy and NetSH. And then we'll show branch cache working because I've got it set up. Yes, sir?
How often is the branch cache data written back to the file server? Was it immediate or when it's saved?
So the question is how often? When identifiers, when data changes. Okay, so if the data changes, we need to write back a new identifier.
And then does the clients in the head office know that file is open if it's being used in the branch cache?
Okay, so do clients actually know if the file is already open? They have to match their identifiers. And we're not doing a check-in, check-out type scenario. It's not SharePoint in that regard. It's just about accelerating the movement of the files down to the user's machine.
Building on that, does that actually put a file lock on the head office server? If you have one person in
Okay, so
just looking at
question is, does it do a file lock, and how do we do writes? It's the last writer that actually wins.
So you can lose data.
We have it. There's a very small. That's where you kind of look at SharePoint, and we support SharePoint in this regard as well.
So it doesn't lock the file on the head office. So if you've got to open in the branch, somebody can see we can open it in the head office.
Well, no, BranchCache is actually reserving the way the file actually works in a normal case, even if you weren't using BranchCache. Okay, so in a normal file server, they would say that file was open. Okay, so we don't allow them two people to open up the same file at the same time. Okay. Yes, way up the back.
Is there a solution, whereby you're utilizing some of the benefits of BranchCache with DFS, or are they still courses for courses?
With what? Sorry.
DFS.
Oh, DFS. Different scenarios we're trying to solve there.
Yeah.
Yep.
So there's no complementary.
No. Okay, I'm going to switch over to my demo machine. And the good folks at IT lock our machines every 15 minutes, so I have to type my password, which always is fun in front of an audience. All right. So I've logged into, and I have to do it on my server. So I'm connected to a bunch of machines back in Sydney. If you go to my blog, you can see how they're configured. Essentially, I've got a scenario here where I've set up a head office, which is the servers that are set up with the DEN at the front of them. Okay, so those are head office servers. And then I've got some servers called FTC, which are client machines. And the Denver Gateway server is a server that I'm going to be used for caching content that's in on a web server that's in a head office. Okay, so I'm going to connect from my branch office up to that server that's sitting in the head office, and I'm going to throttle the network bandwidth back to 512 megabytes because I got a really cool tool that allows me to do that within software, so that you can see what it looks like over a high latency network. So, first thing I want to go to is to set up a server with BranchCache, so you can see how it actually looks. Let me just go to the right one. Okay, so I've already kicked off the settings for adding file services to this box. And essentially all I need to do is I need to click Next here, click Next along there, and I choose the settings I want to have for file services like I would normally do. And then I just tick this box to do BranchCache for network files. And once I tick that, then we can go through and do all the other stuff that we would do with a normal file server. It's fine. And then install, and we're good to go. And then what you'll get is you'll have the BranchCache service will be started. Then we'll need to go to that server and set it as a hosted server, and we can do that through group policy, which I'll show you in a second. All right, so that's pretty much all you have to do to get that server actually set up, and then that has that role service for file services. Now down on the client, let's go down to one of my clients here and do a NetSH. Oops. NetSH BranchCache show status all. Okay, so what this is going to tell me is which mode I'm currently running in at this point in time. So this is telling me here that I am running in distributed cached mode, which is set by group policy. Now you notice that my local content here, you notice that I've got this new protocol called peer disk. Okay, and I'll talk about what that means a little bit later on. So the peer discovery protocol is there. And it tells me that by default my maximum cache size is going to be 5% of my local hard drive and the location of where that's going to be located on my local hard drive. How much is actually set right now for cache, and some of the networking features that are enabled at this point in time. So this is getting all the group policy settings that are set in my environment. So let's go over to one of my clients that I've got the group policy running on. So I want to actually go and show you what the settings look like for group policy. All right. Let's just change this res because this one wasn't supposed to be at that res. Sorry about that. Okay, so I'll just load up a group policy. So I've got a couple of different policies based on whether I want to set these as hosted cache or I want to set them as peer cache. So right now, I've got one called hosted for hosted and one for cache. And the way that I turn these on and off is I just turn one to link enabled and one off to link enabled. I'll just disable them that way. So first of all, if you look at the settings for hosted cache, so this is, here we've got the ability to turn on BranchCache, which is enabled, and then set BranchCache hosted mode. And if we look at the properties of that, that's the server I've set as my hosted cache server for these. So this is one of my servers that's sitting in the branch. So this is FTC server 01, set that as the hosted cache. And then I can go through and specify the round trip latency that I want to use for in milliseconds. And then specify the size of the client computer cache, which defaults to 5%. You can go and change that however you want to do that at this point. So now if I go back to, minimize that. Okay. Okay, so this is set my distributed cache mode, set my branch cache for network files, and turned on branch cache through group policy. So let's have a look at how it looks for the end user. So what I'm going to do is I'm going to go over to my IIS server. I'm not sure what that's about, but it's not my alarm. So if you go over to here, I'm running a program called Network Emulator Toolkit for Windows. And the Network Emulator Toolkit for Windows, unfortunately, is a internal-only Microsoft application. Sounds like somebody's watch or something like that. So what this allows me to do is it allows me to set my upstream and my downstream connection. So here if I go and set my downstream, what I've essentially done here is I'm setting my latency to 100 milliseconds, setting my bandwidth queue to 512 kilobits. Okay, so that's what I'm going to set my settings for the branch office. All I have to do is hit play here, and now I'm simulating a slow link. So let's go over to one of my clients, and we'll just double check and see what our speed is to the network. And we'll do a ping to Denver-DC-01. Actually, Denver-DC-Denver-. Get the right server. I just want to show you what the latency. Okay, so we're sitting around about 200 milliseconds or something like that. Okay, so what we're going to do is we're going to go up to a web page, which is a standard web page that a user might go to, and we're going to go and download a document. We're going to go and download a document, and you can see what the experience is going to be like. Okay, so we'll download this document. Now what's happening here is that this is simulating a slow link. So this is the experience that a user is getting to just download a 3 megabyte file. They're getting a really bad experience. So what's going on now is that the user went to get this file. We went and looked, did a get on the server, did a shout out to see if that file was actually in the local branch already. We noticed that that file was not there, and so that means we've got to traverse the WAN and get the entire file down to the local machine. So let's wait till that actually loads down. And so at this time, what BranchCache is going to do is it's going to make that file available to other users in the branch itself. So and I'll show you how we're actually breaking the data down into chunks. So let's let that download. So is that a typical experience that you would get in your branch offices? And how do your users feel about that?
Wonderful if they want to do that.
Well, they get to go have a cup of coffee and say, all right, we'll download the latest spreadsheet, and we get to go have a cup of coffee, and everything's good. All right, so let's go over to, now, before I do that, I wanted to show you by loading up a perfmon counter so you can see where that data is actually coming from. Okay, so let's load the perfmon counter, and you notice that the retrieval bytes can come from different locations. In this particular scenario, that particular file was coming from the server. Okay, the cache that you're seeing there is when I did this demo in Australia, in Sydney. Sorry, on the Gold Coast. So you can see where we cached content and where we actually brought it down from the server. So let's go over to my second client, and we'll go over to FTC client 02. And we've got the same counter going on here. Well, let's just go and refresh that. Okay, so we'll go and download the same file. Now, it may or may not do this really fast. So let's just test it out, and I'll tell you why. Because sometimes when you're in this demo environment, you have to go and generate some hash lists of those files. So that's going to, now what I'm going to do is I'm going to download this file again on the other user and show you what it looks like on the other user's scenario. Because what's happening here is sometimes when you set up your demos, you have to kind of generate hashes of files so that you can actually, it's kind of like warming the server up at that point in time. Okay, so we'll just wait for that to download, and then I'll go to the other client and download the same file again. So let's go over to, now here you can see where that content's coming from. Okay, so that content now is coming from the server. And we also support, you can see we've got bits, we've got hosted cache, local cache, and then we've got the SMB files. You can see this is using the WinINet protocol. That's where it's getting the data from. All right, now let's go over to the other client. And we'll download that same file again.
Is that the machine that you're on when you downloaded it first?
Yeah, but I'm going to replace it, and I'm going to show you where it's going to get it from. Now, see the file's there already. We're just going to hit save, and we're going to replace it. And it worked in Sydney. That's all right. Let's try a different document. Let's cancel this for a second. Let's do this one. It's demo gods, you know. That's the way life is sometimes. All right, you see how quickly that went down? Do you wonder why that happened that quickly? Did you see that pulled it from the cache? Right, now if we go over to because it's had time to actually load that document, so if we go over to the other client, and we go into my documents folder, you see that legal policy document is there. So instead of it pulling it over the WAN, it's actually grabbed that document from that other user and pulled that across the local network as opposed to going over the WAN. So that second time it did that, and it was okay. Does that make sense? Hope? Okay. Now, I want to go into just a little bit of detail about what was kind of happening end-to-end, actually, what was going on, and what was what details were going on in that particular scenario, because I know we've only got about 15 minutes or so. So what's going on at this point in time is we're talking about content identifiers. Okay, so how do we identify data? When we look at data itself, and this is represented down the bottom here by a square block. Okay, so this is content that might be sitting up on a server. So what we do with that data is we've got the content. We break that down into what we call a unit of discovery, which is a segment. And these segments are 32 megabytes in size. Okay, so We take that data, we break it down into 32 meg segments. This is the discovery where we're actually seeing the discovery of the data. Okay? The next thing we're going to do is we're going to take that data and we're going to break this down into 64K blocks. Now these 64K blocks are what we call units of download. Okay, so when a user needs to grab the content, that metadata that I was talking about to pull that down, that's 64K in size, and what we end up with is we end up with 2,000 times the data reduction. Okay, so what we then do is we take that and we turn those blocks into hashes, segment hashes and block hashes, which gives us a 2,000 to 1 ratio of how much data is going to be pushed down to the user. Okay, so the second time it comes down from the first user, that is actually going to be a lot smaller in the data itself. Okay, so when you further look at this, this is kind of the flow of what we actually have. Now, when I did that HTTP connection to the server, this is what was actually going on. So this is kind of a standard situation for a client and a server. Okay, so on the left-hand side, we've got a client, and that client may or may not have a server sitting in their local branch. They may have just running in peer discovery mode, and there's a couple of ways that we do that. So we have IE, we have WinINet, and the BranchCache protocol on both sides. So we've got IIS, HTTP/SYS, and BranchCache. Okay, so what happens here is that user goes and opens up that URL. They do out of their browser, they go and open up that URL, and they communicate through HTTP.sys. Okay, so they go and grab that data through WinINet. Now what happens here is the server will go and, well, the client will actually say, I am BranchCache capable. Okay, it tells the server when it's going to grab that file that I am a BranchCache capable machine, and it communicates that through to HTTP.sys to tell HTTP.sys that it is a branch capable machine. Okay, remember when I talked about that discovery? What we'll do is we'll throw out a peer, on the protocol itself, we'll throw out a peer disk to do the discovery of the data. Okay, so that tells us that we are a branch capable machine. The server will go up and get the HTTP.sys will go to IIS and grab the data that the user is looking for. It will then push that data down into HTTP.sys. Then it'll take the data and it'll dump it into BranchCache, and it'll segment the data into a hash list. Before I was talking about the hash list. Now the hash list is sent back to the user, and we have to match those between users in order for us to cache the data. Okay, so then what we'll do is we'll take that list of data, we break those 32 meg chunks into hash list. The hash list is then forwarded up back through HTTP.sys. Then it's moved across to WinINet. It's generated, it's dumped down into the hash list on BranchCache. Okay, so the cache is actually stored. That hash list of files is stored on BranchCache. Remember I was talking about we store 5%, we use 5% of the user's local data. What we're doing here is we're storing a hash list of that data. And then at the same time, what we'll do is we'll either do a shout out across a multicast shout out across the branch to say, does the user have this data? Or we'll go to the branch office server to do that. At the same time, we'll push that data back up into IE. Okay, so at the same time, we're pushing that data faster up into IE. Now with SMB and SMB signing integration, it's a little bit different. It's a little bit more things that are involved. So this is the same scenario where we've got the left-hand side is the client, the right-hand side is the server. We have a CSC driver, which is a client-side cache. We have a client-side cache in SMB that we actually use. So essentially what happens is that an application will request a read file from the client-side caching driver in Windows. That will then go and say, I need to prefetch that file. It'll communicate through the client-side cache service. And then it'll request hashes of that file from the SMB client driver. And again, then it'll go over to the SMB server driver over on the server to say, I'm a client that is BranchCache capable. Same as it did on HTTP.sys. Then it'll go and access the hashes that are stored in the cache on the server, send that hash back over through the SMB client driver, up through the client-side client-side service, and then over to the BranchCache that's sitting on the client's machine. Okay, the data is then forwarded back through to the CSC driver, and at the same time that we load the data to the application, we store it in the user's local cache. Okay, so that's kind of how it actually looks at. And then over here we have a utility that comes with server that allows you to it's a hash gen utility. So if you want to warm up your servers and get them ready for BranchCache, you can go and request to generate hashes of data so that you can preset that data. And you can save those hashes into the BranchCache for use later on. If you want to get rid of that data, get rid of those hashes, you can get rid of those files out of there as well. Now, a lot of people ask us about security. And this is kind of the overview of what security is actually doing with data as it's transporting through and when the data is at rest. A couple of things I want to call out at here is that when the client is actually broadcasting out, the public client actually multicasts a client ID to find a peer with the data. That's the public portion of this. We have a private encryption key that we have as well. Okay, and that's generated out of a couple of different things, which I'll talk about in a second. So client downloads, if you look at the way this works, a client will download encrypted content from the peer and decrypts them with the encryption key that they were given, which the encryption key is a combination of a server secret and something we've been given from the client as well. And then they will use the content to generate a segment ID. That segment ID is the piece that they actually set out publicly. Okay, that's the bit that gets sent out publicly. And the good thing about BranchCache is we don't compromise security in that we work with all the current security mechanisms that are there. The standard authentication that we would authenticate on the domain. We preserve ACLs that you might have on servers and that type of thing. So everything is preserved in that regard. We don't compromise the security. Cache data, though, is stored in the clear. Does anybody have a concern with the cache data being stored in the clear? No? Okay.
Is it segmented when it's on the cache?
Is it segmented? So the question is it segmented when it's on the cache? What we do is we have that piece that has to be matched up, okay, with the one that the other client has. All right. This kind of breaks it down a little bit better. So I apologize the way this diagram is probably a little bit much for you after lunch, but you are getting coffee soon, so it's all right. So this is kind of what, remember I talked about those blocks before, okay, in that diagram where I was talking about how we broke out the segments, the blocks, and the hashes. This is kind of what we do. So from those blocks, we further create block hashes. Okay, so, and this kind of, I'll build this out. And then what we do is we create a HOD, or a hash of data. Okay, so essentially what we do, we create a segment hash of that data. Then over here on the server, there's this other little bit on the server called this, the server secret key. Okay, we take that server secret key and the segment hash of the data that we've created from those block hashes, and we create a segment secret. So this is KP equals hash plus the HOD and the server secret key. Okay? Then what the client publicly shows out on the network is the segment ID. Okay? The encryption key is not ever made public. Okay? Then the reason we're doing that is there's a scenario that we're kind of thinking of here that might be very, very hard for a hacker to actually guess. Say you know that your boss has a spreadsheet, right? And you know that there's some confidential data in there. And you want to kind of piece that data back together. And this is the reason why we have the secret key, so that we can stop people trying to take data and manipulate it and put it back together again. And it's very, very hard for them to guess. Okay, so this is kind of why we do it this way. So this is kind of the flow of that whole security and what we're actually doing, the flow of how it works. So the client will go and request data from the server. Okay, then what the server does is they'll do an auth on that particular client to make sure that that client is got the rights to get that data. The server retrieves those content identifiers, those block hashes, the segment hashes, and the segment secrets for the data. Then what the server does is it sends a content identifier on the same channel. Okay, and then what happens is the client will then go and broadcast that client commutes a segment ID and do a multicast of that segment ID on the network. That's when they then have to match that up with the other client to make sure they get the right data. Then the serving clients receive that broadcast, and this is where they do their decryption. So they decrypt the segment hash from the segment discovery key. Okay, and then they respond to say with data availability. And then the client requests the blocks from the serving client, and the client computes the encryption key from that segment secret key, and then the serving client encrypts each block with the encryption key. They decrypt the data, they validate it against that block hash to make sure that block hash is the same, and then, if valid, they return it to the application. Okay? Now, a lot of people ask about what about security at rest? So on the client, the cache only contains content requested. Data in the cache can be ACLed, so that accessibility if authorized. If you're worried about data leakage, then you can use technologies such as BitLocker. So we use AES 128 encryption, and we also do a SHA-256 hash on the data itself by default. So the hosted cache contain content requested by all branches. Use BitLocker and EFS on those servers as well, because we support it on the server as well, if you're worried about content in the clear. Now, the other thing is content can actually be purged periodically from NetSH. So if you want to clear content out, you can go and purge that content through the NetSH in the cache. Now, I wanted to give you a kind of a scenario about what we're actually seeing around internally. We have a white paper that you can get from Microsoft IT Showcase, and it talks about how much data how much money they're actually saving around caching of content. So this is a sort of a snapshot of the overall bandwidth utilization that they did during their pilot. They tested this with around 16 to 20 gigs worth of data, and they saw that 71% of the data was actually being requested via local cache, as opposed to all of it going over the WAN. So we're implementing what we call VBOS servers in branch offices. Here in New Zealand, we've got one over here. And it allows us to cache HTTP requests. So if somebody's going to a HTTP server in a head office, we cache that content on the local hosted cache in this office here in Auckland. So what it does is it saves us a lot of money over the WAN, so that we're not sending so much data. Because what typically happens when your users say that the internet is slow? They just want you to throw more bandwidth at it, right? They don't understand. Yeah, I've got ADSL at home and it's really fast. Just throw more bandwidth at it. But that costs a lot of money, right? What this allows you to do is cache that content instead of having to go it over the WAN itself, which is expensive. Oh, that didn't come out very good on that slide. Anyway, we've got Cisco makes a WAN accelerator appliance, Citrix and Riverbed. So we are partnering with Cisco, with Citrix for their different WAN accelerator appliances that they have, and Riverbed supports the BranchCache protocol as well. So we do have a number of partners that actually working in this space. Sorry about that slide. So it brings me to the end. We've got about 5 minutes for questions, and I've got to give away T-shirts. So this is when you go, does anybody have a question? Because you know you're going to get a T-shirt, right? Yes, sir.
That BranchCache works on the file level or the smaller unit level. Say if you have a client that's already got the file, maybe portion of the file cached, the other client, can it get it, or it needs to get a whole file from the server end?
When you go up and get that metadata, okay, so if the client has only pulled down part of that file, what we tend to do is we don't cache content that's less than 64K. And then the reason why we do that is so that because the actual segment sections are actually 64K in size, the blocks of data are broken down into 32 meg chunks so that you don't get that scenario where you only download portions of the file. So if the client, for some reason, doesn't have the entire file, they're going to go up and look for that hash ID, and they're going to have to have the entire file on their machine before they can cache it. Okay, so they can't cache it unless they've got the entire file in their cache.
Doesn't matter what size of the file is?
No. No. So which size would you want? I've got a medium.
I think a small.
I only have medium and 2XL, which is normally the tech ed size. No offense to anybody. I've got 2 mediums and a 2XL, so I'll give you the medium. Anybody else got a question? Can I go up the back? I'm going to go up to the guy in the white shirt there. I saw you first.
With peer-to-peer,
yes.
using group policy, can you basically stop your laptops from being able to cache?
So the question is, can you stop your laptops from?
Yeah, so obviously they're going to be more effective outside the building.
Yep.
From security aspect, can you do that, or is it literally per site you see that?
Well, because in peer distributed mode, we only support the single subnet. Okay, so if they move outside that subnet, they're not going to cache.
But can you basically set some clients on that subnet to cache
Through NetSH you can, yes. Yeah. So what size do you want, medium or large? I'm going to try to do a frisbee shot to you, but we'll see what happens. So, no, not bad. A little wind was in the air. So who had the next question? No. It doesn't work like that. It doesn't work like that. Yes, sir.
Does it improve file printing at all, this BranchCache at all? So if you've got your print server sitting in the head office and you've just got to spool the print jobs down to printers in the branch, does it improve performance?
I don't believe so because it's only supporting the protocols I put up there, which is SMB, 2.1, HTTP, HTTPS, and bits. I don't believe printing is using that type of protocol. So no, it doesn't. But you do get a shirt. The only size I have left is XL. Is that okay? Any other? I will take more. Sorry about that.
Saving the file.
Yes.
Can you explain the process that happens when the file is saved?
That was a lot of read. What about all those changes? Because typically we're going to make changes to those files.
Yes. Okay. So the question's around user has the document open, for example. They make a change. Once they make a change and they save it, then we have to generate a new hash ID. Depends. It depends where they save it. If they save it locally, then obviously we've got another version of that file, right?
Yep.
So then we have to go and match the hash ID. So we're going to download it again. Remember, we're not doing check-in, check-out type scenarios. We're not a SharePoint solution. We're only about accelerating the files that they already have in the environment.
Storing your files that you use to be changing anyway and saving them back to the server.
Once this change on the server, if they're saving it in place, where they got it from, obviously that's going to save it up to the server, right? Because they've opened it from the server. So if they do a save, that saves it up to the server.
And does it automatically put it down to the local?
Yeah, they'll have that cache there locally.
That file's been served from another PC from inside. They've got to make the change.
So the question, so I didn't hear the whole.
If the files you're saying,
Sorry.
I just thought about it. It doesn't.
No, that's okay. That's okay. That's fine.
Under what circumstance would you delete the branch cache? Because you clear the cache out periodically for some reason?
Yeah,
Out of date or
so the question's around at what point do we do that? We do that periodically when data becomes stale. So data that hasn't been touched for a while. I'd have to check the exact times, but we do that periodically. You can also go do a NetSH BranchCache and flush the cache if you want to.
So is that the cache on the servers? Or
Either place. Either, because both clients support NetSH BranchCache interface. Okay, both client and server. Yes, way up the back, sir. So the question is, can you configure when you want it to flush? I don't believe so, no. Pardon me? Shadow task could do it, yep. Yes, sir.
If you have a hosted cache in a branch,
Yep.
do the clients still need to see Windows 7?
So if you have a hosted cache in a branch, do you have to have clients on Windows 7? Yes, you do. Yes, you do. I was waiting for that question. Here's what I would say to that. Let's get over XP. It's done. XP is 10 years old. We're not going to be putting anything back into XP at this point in time. Yes, sir. Pardon me? I still didn't hear that.
The demonstration, I presume, was a distributed cache model. Why did it not work?
Because at that point in time, you have to go and generate some hashes. You have to warm up the server in the demo environment, particularly.
But it was distributed, wasn't it? So
Yeah, I had to generate the hashes on the local client, and that I picked a different file that was there. So it hadn't actually gone out to the network and did a multicast shout out to that yet. Once it actually does, the other file was already there. Camilla went back to the other client. The other client had another file that was there that was already in the cache. So it does take a little bit of time for it to do that multicast shout out. It's not an instantaneous process. Yes, sir.
Does BranchCache even integrate with like your internet-based files and that sort of stuff? So if the guys are browsing quite a bit, does it cache those as well and cache them locally?
So the question's around if they go out to, say, Facebook.
Yeah.
No, it's only looking at internal at that point in
But
time.
then will it cache if you had to enable it on like your ARSA-based services with proxy cache and all that sort of stuff? Does it do anything around that?
I don't believe so, no. Not at this point. Yes, you had one up here at the front.
Any domain function level requirement for this? You know, like Windows domain function level.
Oh, so the question's around what domain function level. You don't have to raise your 2003 domain to 2008 or anything like that. You just have to have the server that's actually going to be doing the caching has to be on R2. So before you guys go, make sure you fill out your feedback forms. That is important. And I believe they're giving out prizes and they're doing this tweet a nugget and win. So the hashtag for TechEd New Zealand is TENZ and #nugget on each tweet. I've seen a few of those out there already. So I want to thank you guys for coming along. I appreciate you taking the time. And hopefully see you again soon.
Sorry, Jeff, did you mention the client?